Well, hello everyone. This is KP the Math G, and I am just happy and delighted to be here this evening. I have I believe, a really good, solid problem that you might be interested in. It comes from the 2000 AP exam, the free response. Question number 4. I also have, I want to say, a question number 3 as well. But just looking at this, I took a little time to look at some videos. I mean, not videos, some free response questions. Yeah, I got also number 2, but I'm going to wait on number 2. I'm kind of anxious to do number 4 first. I abbreviate some of my words here, so because my board, I just want to have a little space to do some of this. I don't know if I will do all 4 parts to this, okay, but I will probably do the first 3 and then save the 4th one for another video. All of these are good questions. These 2000 questions are really nice. I've studied from 1998 till present, and I'm just kind of seeing a pattern throughout even just those few questions. And believe me, I guarantee you could probably go to 2010 and see something like this up here. Let's examine the question at hand. Water is pumped into a tank. It is at a rate of 8 gallons per minute. Alright, so that's a rate. Water leaks from this tank at a rate of t plus 1 raised to the 1/2, or the square root of all that. This is gallons per minute. Okay, so then how many gallons? And the first question is, how many gallons leak out? So what you want to pay attention to is, first of all, this is a quantity, how many gallons. So when I'm seeing that this is a rate, when I take the when I want to get the number of gallons, remember, we take an antiderivative, right? In this case, a definite integral, because we're going from 0 to 3, so we are doing that right there. Now, how to set this up, because we're just looking at the rate that the water leaks out. Here it is right here. That's all we're interested in. We don't want anything else, okay? Alright, let me get probably another color. My ink is starting to fade on me. I'm going to have to get some more of it pretty soon. Alright, so here we go. T plus 1 to the 1/2 dt. Alright, I do believe that was the problem itself. Yeah, that's it. Oh yeah, by the way, we'll look at this later, but the tank already has 30 gallons of water, which we're not interested in that right now. How many gallons leak out from time t equals 0 to t equals 3 minutes? That's what we're looking at here. That's the way to set this up. Alright, so anyway, this is a substitution problem. So we're going to let t plus 1 be equal to, or I'll say u maybe, u be equal to t plus 1, and du is equal to, and the derivative of t is just dt. Alright, like that. And so what we have here, with just over here too, well, we can do this, and I've done it without even doing but I might show you how to do it later, okay? If you know you're just going to get du equals dt, you can make this really simple, okay? And I'll show you in just a moment. Alright, so anyway. Alright, so what we have is u to the 1/2 du. Alright, just like that. Okay. And of course, you know how to do that. That is going to be, you're going to add 1 to 1/2, so 2/2 plus 1/2 is 3/2, and remember you can divide by the 3/2 or you can simply multiply by 2/3. So what you have is this is equal to, alright, so 2/3, and I'm going to go ahead and substitute, well, okay, I might not, but u to the 3/2, and right now I'm not going to put the numbers there. I just want to show you this right here. Okay, now u is, okay, so now u is t plus 1, so we have 2/3. I'm just going to leave that on the outside. Alright, so t plus 1 to the 3/2, and actually if you want to, you can, yeah, we'll do it that way. Alright, t plus 1 to the 3/2, and we are going from 0 to 3. Alright, limits of integration now go up there, okay, and now we can substitute those back in there. If you already know that this is going to be this right here, okay, without a 1/2 or whatever, or even if you know what's going to happen here, you can just go ahead and go straight from here to here if you want to do that, okay. Alright, and then now let's see what we have here. This is 2/3, and then we have 3 plus 1, and remember this 2 is the index number. That's the square root right there, okay. So that's the square root of 3 plus 1, and then we're going to cube that. Alright, and then of course minus 0 plus 1, okay, we're plugging in the 0 here, the square root of that rather, okay, the square root of that, and we're going to cube that. That's what the 3/2 stands for. This is the index number, that's the square root, and then this is the cube right here at the end. Alright, and this is what we have here. The square root of 3 plus 1 is 4, which is 2, so we have 2/3 times the square root of 4, and if you don't want to put that there, you can go ahead and just say 2 cubed, which is 8. If you can go ahead and say that's 8, that's fine. 0 plus 1 is 1, and the square root of 1 cubed. Okay, so this is actually 2 cubed. Alright, so 2 cubed minus 1 cubed. Alright, that's equal to 2/3. 2 cubed is 8. 8 minus 1. 1 cubed is 1. And that's actually equal to 2/3 times 7. 7 over 1 if you want to. So 14/3. So this is equal to 14 thirds. Alright, so that is what we're talking about. That in the units are gallons of water. Okay, that's leaking out. Alright, there it is. 14/3. That's the A part of this question right here. Alright, 14/3. That's, so, let's see, 4 times 3 is 12. So 4 2/3 gallons of water is leaking out. But I just leave it right here. Once you get down to that, that's good enough there. Now, again, when do you integrate? When you take the derivative. If you have a rate, you have to integrate the rate to get the amount. And I've been saying that in several different other past videos. Okay, if you take you integrate, you want, this gave it away that I'm going to integrate. Okay, it gave it away. Let's also be aware that there are, let's see if I can find my marker here, right here. There's already 30 gallons in the tank at, T equals zero. T equals zero. Okay. That's what we have here. Already 30 gallons. Keep that in mind as we look at other problems. Okay. So, pumped into the tank, 8 gallons per minute. We didn't have to worry about that because the first part was leaked out. Okay. How many gallons leaked out? Okay. So that's what we figured here. Now, part 2. Let's look at that. I'm just going to turn the board over. Let's see if we can do part 2. Keep in mind there's 30 gallons already in there. Alright, at T equals 0, a rate in is 8 gallons per minute. I'm just going, there we go. Rate out. Okay, going out, we have the square root of T plus 1. Alright, and that is in gallons per minute. Okay, that's what we have so far. And that's what we just need to remember. Okay. Now for the second part is how many gallons of water are in the tank at time T equal 3 minutes. Now we got to take in consideration the water coming in, the water leaking out, and how much we already have. So we already have 30 gallons. Alright, so 30 gallons. That's what you do. You start off with how many you have already. Alright, at any time. This is 30 already. Now, we also, we're looking at, I want to say this is, how many gallons are at time T equal 3 minutes. So, how many, again, how many? That's a quantity. How many gallons at T equals 3 minutes? Alright, well, we already figured out how much is leaking out. What I want to do is now we know that this is 8 and it's in terms of T. Isn't that right? We're taking the antiderivative, or we're taking the definite integral of 8. That's what it is. Okay, and then of course we're going to subtract off what we found from our last answer. We already know what that is. We don't need to redo that. We found that to be 14 thirds. Okay, so 14 thirds. So that was from our last answer right there. In 3, from 0 to 3, we turned out. So we don't need to do that. If it had been saying, let's say from 0 to 2, we'd have to do this again. Or from 0 to 4 or whatever, but it said from 0 to 3. We've already figured out how much water is leaked out from T equals 0 to T equals 3 minutes. We already know that. 14 thirds gallons. No, not per anything, just gallons. This is 30 gallons. This is minus 14 thirds gallons. This is going to be in gallons as well. rate. This is a rate, so I take the antiderivative here. Alright, well that's simple enough. This is 30 plus, now from 0 to 3. This is just 8t right here, isn't it? Right? Minus 14 thirds. And if we start plugging that in, we'll be alright. Let's see. So 30 plus 8 times 3 minus 8 times 0. Alright, minus 14 thirds here. Make sense? Alright, just try to make sense out of this, because this is how many gallons. Alright, there it is. And that's the pattern. 30 plus, alright, like that. Now we're going to get this as 24, so 30 plus 24, this is 0, minus 14 thirds. This is 54, so equal to 54 minus 14 thirds. And again, I just want to multiply 54 times 3. I want a common denominator. 4 3s are 12, 5 3s are 15, 162. So this is equal to 162 over 3 minus 14 over 3. And I'm getting something over 3. And when I look at that answer, it's going to be 12 minus 4 is 8. And then 5 minus 1 is 4. So 148 over 3. And what is it? What's the units in? It's in gallons. Alright. That is how many gallons are in the tank from t equals 0 to t equals 3. We're losing this, we've lost this much already during this time. This is how much was already in there. So this is how many gallons that are left. And if you want to divide that, you will find that it's going to be over 30 gallons. Of course it will be, unless this rate goes out faster than this goes in. That's the only thing you got here. But that's not the case. 148 divided by 3, 4s are 12, 3 9s are 27, so 49 1/3 gallons are in the tank from t equals 0 to t equals 3 minutes. Alright, there you go, right there. That's what you're looking for. That's probably what you got to write down on that page. That's really nice. I love this problem here, and that's why I wanted to show it to you. Okay? You have to be aware of what you're looking for. How many gallons are in this tank? You already had an initial amount of 30 gallons in there. Some's leaking out though, but some is going in. Okay? This is amount plus another amount minus another amount. Okay, that's what you do there. Then go to the other side again. Okay. And maybe we can answer part C. Alright. I could probably end this video now. I think maybe we need to go ahead and look at it. This is not going to take a long time. Alright. Please bear with me. I do appreciate you tuning in to this video. I think you'll find that you can get a lot out of this. I believe you can. I know I did when I did it, and I'm enjoying doing these problems. I've done several problems coming up to this, and I just found this one, and I really wanted this. I felt the urge to to show you this one here. Alright, let's look at one other thing. Now, we want to express the total, this is C part, the total number of gallons at any time at time t. And usually in the question, and didn't ask it here, but usually it's at any time t. Well, we're not just going to be limited. We know that it's, well, we know that it's 30, right? And we know we've already found this, but any time t is going to be t. That is any time t. Not limited to just 3 minutes or 5 or ever how many minutes. It's not that, okay? At any time t. We know that the amount going in is 8. That's how fast it's going in. But you remember when you take the antiderivative or the definite integral of this, well, that's going to be an amount. This is an amount here, okay? All right, so minus, and instead of putting t here, since t is already here, we're going to make this x plus 1, okay, all of that, and all of that dx, okay. Since we have it in terms of x here, we will put dx here, but we're going to substitute t in that place. That is the general answer right here. Now, can we go a little further? Maybe so, yes. We know that this antiderivative here is just simply 8t, right? Okay, hold on. I'm dropping paper on the floor. Okay. Alright, right here, yes. Alright, and then minus, and then just move the, alright, and then the square root of x plus 1 dx here. Alright, and that is one way to go about doing this. I would ask my professor or instructor, teacher, whoever's doing this, if this is acceptable here, okay? But this is the general. This is any time t. You're going to have the initial amount that's 30. You already know that. All right, plus this amount minus this amount. So we just put them two together with dx here. And we already know that when we integrate this, this is 8t minus 0, which is just 8t. Okay. So there's that part right there. And then just do this again here. All right. So that's it. That is it right here. I don't know what they say about boxing in answers either. I'm not so sure about that, but anyway, I did box it in. That's the general right here. And if it says, I want to say this is a at t, so if we want to do this, so a at t equals, now 30. Okay, so equals 30 plus, now there we go, and there it is, at any time t. This is the total amount right here. Okay, this represents the total amount at any time t. Okay, so just kind of be aware of that. There's one more, and I think I want to reserve that for another time because it can be a little bit confusing. So I'm going to have one more video on this. I have others that I would like to do also. I'm interested in you understanding one that has to do with, again, velocity and acceleration and total distance. I want to get that. I don't know if I have anything. Yeah, total. Yeah, all of that. And then I want to get something that deals with a particle. That's actually, yes, a particle moving along the y-axis. I don't know if I'll do that one or not. I may do that. And then there is one that has to do with a solid that's bounded by the curve and a line, and we need to find the area of that enclosed section and revolve it and so on. That's a really good, the part C is really the part that I want to show you there on that one. So I've been looking, starting again with 1998 and to this present time here. We're at the year, and I think one of them does back up to 1999. Yeah, 1999. So yeah, I'll be doing that. I'm just going to move on down and till we get to as far as we can get with this, okay? And just kind of keep giving you some of these videos that you might need here. And then eventually I want to start on some other new calculus as well, on some of these things here. So anyway, I trust this has helped you right here. I know it really did help me to study it. I really enjoy studying this kind of thing. But anyway, it's really nice. And again, I appreciate you so much for tuning in. I hope you continue to tune in. I really enjoy doing this, as I've said before. And if you will, if you haven't subscribed yet, please subscribe. I hope you do. But then again, you don't have to, but I would like for you to if you would like to do that. And then hit that like also, or make a comment too if you want to. Alright, that does it for this episode. Let's say this is now the 82nd video that we'll be looking at. This is KP the Math G signing off. Have a great rest of the day.